Two ways of figuring out the area between graphs. Either you are in the CAT scan and then you tell the computer, okay, I want it to scan from where I'm standing, from here to here, but that's the whole rectangle, that's too much. Then you tell the CAT scan, or whatever it is, the computer, okay, the shape of my head is like this, and the shape of my legs is like that. And then when it starts scanning these shapes, it finally recognizes the area of this particular object. And that's the whole idea here. Scanning from left to right, top to bottom. Top minus bottom idea. But what if it's convenient to scan the other way around? When you have a rectangle from top to bottom, but then curves left and right. Then you tell the computer, okay, do the whole thing from C to D on the y-axis, and then there's a curve on the right, say my right hand, and then the curve on the left, my left hand. Scan from here to here, and that makes the shape right minus left. The whole idea is always the same. It's bigger minus smaller. So either the function is always on the right and always on the left, or always on the top and always at the bottom. If this is not the case, then you break it into steps, which we're going to have in your homework as well. I taught you the formulas, which is top minus bottom, and then right minus left. It's always bigger minus smaller one. Whatever is on the top is larger than the smaller one. On the bottom, on the right, is bigger than the one on the left. We did one example. Remember, the answer should be positive. It's the area. We did two examples, actually. But the important example was we built a parabola, and the line, parabola was on the top, line was at the bottom. So we chose case one. Chose. What is that? Choose. I was deciding between choose and chose. That's interesting. Let's do chose. Chose the case one. Let's do case two and then move on to another topic. Example two. Example two. Let's have a nice example when we have everything on the right versus everything on the left. Sometimes it's not that simple, as you understand. They might be mixed examples. Then you have to figure out where to make a break and what to do with that. So, let's see. Case two. The hint. Oh, this is the good one. Weird cases. The weird cases I want to show. So, note. Let's do the note first. Note. Shapes are not that convenient, okay? What if there is this kind of tent that you see in the restaurants in Arizona? That's shades, those shades. So they make good temperature. What about these ones? That is not very clear what is happening. So for cases like this, you sometimes break into two cases, A1 and A2. And then for each, you choose what to do. Top to bottom, or the right and left. That is interesting. So, I guess I will have it here. So these cases are also good. And finally, cases like these, the symmetrical cases, these ones are also very good. For example, there is a cubic function, and then the line that crosses through. So in these cases, you can only find one and then double it, but don't forget to change the sign, whatever is below or above the graph and stuff. So that is also important. Is there any x?
So it's, wait, this is for plotting area, right?
Yeah, this is area between graphs. So,
so something just split it.
Something is just split it, yes. So let's do the same example we had before, but type 2. That's what I wanted to show. I just did, it's kind of not too bad. The same example we had before, which was y equals 5x minus x squared, and then y equals 2x. But we want to check if we can do it case 2. When we draw this, when we sketch the graph, again, you don't have to be precise, but you do see that this is parabola concave up, parabola concave down,
Sorry, my brain.
And then the line y equals to x. The parabola actually goes through 0, 0, so change that. It goes like so. So this is the area. Last time we decided to see it as the top minus the bottom. But you have to be creative. Sometimes you can see it as right minus left. And I want to show you that kind of scenario. Okay, that is a pretty cool idea. So if you want to do, let's try case number 2. And case number 2 is right to left. From right to left, right minus left. And this is a cool thing because some shapes are the same, are at the top at the same time being on the left. So the parabola is on the top, that is true. But it is also on the left. So the red parabola can be seen as a function on the left, while the purple part line is on the right. When you're talking about this shaded area over here. To check that, you can always see like, okay, this one is always on the right, and this one is always on the left, from right to left, from right to left. Then we will choose case 2, if you want to do that way. The extra step for case 2. Case 2 requires the integral in terms of y at the end. Integral dy. So the function on the right should be in terms of y, and the function on the left should be in terms of y. So the function on the right minus the function on the left versus top minus the bottom. And since we're describing y variable in the integral, the limits of integration also have to be about y. So c and d. This is what I'm talking about. But the functions are not given in terms of y. So we need to solve for x. And it's the extra step here. So solve, so that's a solution, solve for x. So we need to have the situation x equals and x equals for both functions. Solve for x. Solve for x, the functions which are given. It's easy for function number 2, so let me name them again, 1 and 2. For the function number 2, we're going to have x equals y over 2. Okay, that one was nice. This is also a line, so it's going to be on the right or on the left. This is my equation of the line. I'll write down like so. X equals y over 2. I'm signing lines and curves here, but using x equals blah 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 notation. Yes?
To clarify, this is considered an impractical solution because it's formatted the other way, right?
Not necessary. Sometimes it's better to integrate this way. The integral might be hard to integrate the other way.
Well, what I meant is this impractical in this case.
In this case, yeah, I agree.
The equation is already solved for y.
Exactly. Since the equation is already solved for y, it kind of makes sense to use the case 1, but sometimes it's impossible, or integral is impossible. So you switch to the other case to see if it's better.
I wanted to clarify that I understood.
Now, how about x? Can we solve for x or not?
On case 1?
And that is the problem. X, what is happening with equation number 1? Can we even solve for x from the parabola y equals 5x minus x squared? And the answer is no. And this is how you know you're not supposed to do it this way. So graphically, you can do it from right to left. Practically, you cannot. So cannot solve for x in real numbers. In complex you can, but for real you cannot. Which means I can give you a better example. Well, this is example when you know when you're stuck.
You can't without dividing by 0.
So the idea is you need to be careful with this. Which one you choose? Well, on the exam we tell you which one to choose. But if you cannot solve, probably something is wrong with this. And then later, we usually in upper level classes, take into double integrals and see what's happening there. So the last example I will show you, when it's actually doable. So this was a nice example to know when you're stuck, then just don't choose this method. So if you have 9x squared minus x equals to 0, and then x minus, it's a different example.
I'm sorry, no, sorry. Never mind. I was being sure you said 9x squared, and I was worried that
9y squared minus x equals to 0. X minus 2 equals 7y squared. We're finding the area bounded by. Find the area bounded BDD, that's bounded, Bounded by, that's nice American notation for bounded. BDD. Bounded by. Step 1 is the same. You sketch the graph first. And that's why you have your graphing calculators. They should help you, or Wolfram Alpha, they should help you. What I see two parabolas here. If I see y squared and the other variable is not squared, that's usually a parabola. This is the parabola tilted to the right or to the left. So when you tilt your head, it should be looking to the right or to the left. Since both of them have minus in front, I would say y equals x squared. Yes, plus in front of each. Those are smiling parabolas to the right. That's how you know it. So I will sketch x and y, and you have two cases. One gives you 0, 0, that's equation number 1, gives you 0, 0, 0. So that one will be touching 0 and smiling to the right. Let me write it down. This is 9x squared, 9y squared minus x equals to 0. And the other one is shifted by 2 units to the right.
Wait, how are we graphing before even solving? What do we need to solve for?
You just graph it. Okay, I can explain how to graph it. Either you use graphing calculator, or in my case, I kind of just know how to do it. Let me show you how.
But you can't graph a graphing calculator unless you solve.
No, I can. So let me show you. You see, both of these are parabolas. One is x equals 9y squared. This is what you call it for solving. No, not necessary if you can do it just right away. But okay, if you want to, I can do it. So for the equation number 1, x equals 9y squared. And for the equation number 2, x equals 7y squared plus 2. So 7x squared plus 2, this is the shift by 2 units to the right. And that's why when I plug 0, 0, when I plug 0 for y, x is 2. That's how I know that this should be shifted by 2, like so. And this is the area bounded by.
Sorry, I was...
Okay, good. So this one still can be done as top minus the bottom case. However, it should be breaking into cases. Too complicated. If you want to do top minus the bottom, you could do it as area 1 and area 2. But we're not going to do that. That is overcomplicated, a simple case. So what I'm going to do instead is I will do it right minus left case. Besides, all functions are already solved for you in terms of x. So that gives you a good hint. If you see x equals and x equals, then it's a good hint to use case 2. We're choosing case 2. Case 2 is right minus left situation. And that's why I'm signing all the functions. I need to choose which one is on the right and which one is on the left. Red one is on the right. Blue one is on the left. So the integral will be in terms of dy. So the area is the integral between two graphs. One is on the right. Which one is on the right? Which one should I write down first? Red one. X equals, which one did you say?
9y squared.
9y squared looks like to the left to me.
Oh,
it goes like this, remember. It goes like this. From the right to left. So right goes first. It's the bigger one. Which one did you say?
I have a question. Since the equation was 9y squared minus x, wouldn't it be negative 9?
Let's see. 9x. Oh no, I did like this. I did 9y squared equals x, right? Because you add x to both sides. And then I flipped the order. That's a good question, yeah. But basically this is what I did. And then it did not look nice in my mind, so I switched the order x equals. So which one will go first? X equals 9y squared or x equals 7y squared plus 2? Yeah, that one is on the right. 7y squared plus 2 goes first. Minus, and the other one is in blue, x equals 9y squared. That one is on the left. So right minus left situation, and y is now changing from some kind of y variable at the bottom to y variable at the top. And we kind of don't know these numbers actually. C to D. So we need to figure out what is C and what is D from C to D. Like so. To find C and D, what do you think we should do?
9y squared equals 7y.
Exactly. Let's find points of intersection by setting the equation. One equals to another one. Because when do they meet? They meet when they equal to each other. So to find points 2, find C and D, find points of intersection. Whoever is on the phone right now, I'll be asking you to solve it for me. So be aware. X y squared plus 2 equals 9y squared. You guys, how to solve this equation? You should know. 7y squared plus 2 equals 9y squared. What is that? How would you start solving it? At least. Put y on one side, amazing. Y squared minus 9y squared. And I would keep the 2 to see what's going to happen. Then what do you have now? So when I combine these two, what it gives me? Negative 2y squared, good. Minus 2. Y squared is 1. Y is plus or minus 1. Amazing, good job. But still don't be on the phone. Thank you. So I got these 2 points I needed. From minus 1 to 1. Thus, the integral is integral from minus 1 to 1, dy at the end, and let's simplify whatever is inside. We already kind of did 7y squared, this is squared, minus 9y squared is minus 2y squared plus 2. And then you finish integrating this. So let me point out, this is how we found limits of integration. The answer will be integral of minus 2y squared gives you minus y cube. Oh, 12. I heard 12, or maybe I did not hear it. Minus 2y cube over 3, right? Minus 2y squared is minus 2y cube over 3. Plus 2 is just integral of 2. 2y, thank you. From minus 1 and 1, carefully plug in minus 1 and 1. If I plug 1 first, I will have minus 2/3 plus 2. I just plugged 1. When I plug minus 1, I have to be very careful because minus 1 cube is minus 1, right? So it will be plus 2/3 now. This one was minus. I will change it in green. This one was minus. This one is plus. Because minus 1 cube is minus 1. Minus times minus gives you plus. And then it's also minus 2.
Wait, wouldn't we have to change that minus sign to a plus sign?
That's what I did. It was minus 2/3, now it's plus 2/3. And now again, you will change it again. But you don't change it, you distribute negative sign. So be careful with that. And when you distributed negative signs and collect it together, I got 8/3. Remember, it should be positive. If you get a negative answer, you messed up. 8/3. Which is positive?
I'm confused. We cubed negative 1.
Yes.
And we're subtracting it. So we need to say we're subtracting a negative number. And therefore it happens.
We are cubing negative 1 and then multiplying by negative 2.
Oh, right.
And then this is also minus 1. Minus, 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 and minus gives you plus, but then minus 2.
Thank you. I missed the step.
Good job. What do you think about this? Questions? Oh, here's the awkward case. I actually have it here. When you divide into cases. But this one, so there's very 2 classical cases. We put one of these on a test and then check it. It will be on our quiz next week. Or this week. I will decide on that. But area between graphs is a fun topic, to be honest. Usually students like it. Steps are very predictable. Steps I wrote for you last time. Step 1, sketch the graph, sign each function. Step 2, choose the case you like, dx versus dy. So we just did dy case. Build the integral, find the points of intersection. That was the intermediate step. If you need them, then find points of intersection. Sometimes you have them in front of you. Finally, build the integral, finish integrating. So I have 4 clear steps here. The area should be positive. So when you choose case 2, I call it dy case. Because it's all in terms of y. Right minus left, and y is from the top to bottom. Not too bad. Then let's do average area today. Average area. Oops. If you have average, R is missing, good. If we know average numbers, like what is the average of your exams, then probably there's such a thing called average area. And here are nice animations I found for you. Look at that. Average area kind of makes sense. Average of your exams is add up all the exams divided by 3 midterms, right? Add up numbers divided by 3. Average area is add up all the areas together and divide kind of by the length of the interval. The dividing by 3 midterms you have is dividing by the number of midterms you have. 1, 2, 3. The total number is 3. Here is the length of the interval. So you're dividing by the length of the interval and gives you average value. So this is your profit of the business. Say you're selling pens on campus, so to get some money. You're selling it and they became popular and people got tired of them and they started buying less. What is the average sale price was, or the number of things you sold? This is the average. So it makes sense. It's literally the average. Here is better. What is the person, number of people, 10 people, and then the average year, 15, 30. So the average year was around 15 years old for some kind of study. So you see, average is up. What is the average comparing to above and below? So we need to learn that. That is a very applicable idea. So always teach it in all classes, to be honest. So suppose f of x is a continuous function. As you can see, we're not supposed to, well, we don't like working with functions which are not continuous. Suppose f of x is continuous, which is continuous function on the given interval. On the closed interval a and b. Continuous means no breaks, there's no vertical asymptotes, just typical function of your business, say, or maybe utilities. How much do you spend on summer for electricity versus on winter? Then the average value, the average value of f of x on AB is, I can see in this book they call it F with the bar. That is not known information internationally, but let's keep it. F with the bar, okay, that's totally local thing to decide, which is going to be, just like I told you, let's divide by the length of the interval from B to A. That's the number of exams you took. So you have 3 midterms, for example, in some kind of class. You have 3 midterms. What is the average grade? You add up the grades, divide by the length of the interval from 0 to 3. That is 1 over B minus A. What is the addition of all the exams in the interval, in the integral notation? Integral collects all the different numbers together. That's what I was trying to explain before. Integral collects all the different speeds, different numbers, outputs. So it's going to be the integral from A to B, f of x dx, like so. And that is the formula. The average value, bless you, is different from the normal integral just by one little detail. You divide by the length of the interval. And that is why that animation I showed you makes sense. Total area, but then you divide by the length and it kind of measures up the average. Bless you. So I can actually put that animation here by doing the screenshot. The screenshot will be like so. You have something going up and something going down. The average is over here. It's the average. So that's kind of the main idea here. The average is something like here. So we're talking about areas. The average area is somewhere on the average. That's the idea. The area under F bar is the same as the area under F between A and B. The area from A to B, the area below the average is like this. This is a rectangle basically. But it will be the same as the total area of the original integral. Integral below F, the blue F. Because F will add up whatever was below and above, just like the animation I showed. It adds up those two.
It's so trivial. It's always so shocking. What?
Right? Yeah, it is very trivial idea here, and let me show you the example.
It's so easy to prove, yet it amazes you every time when you use it.
Yeah, it's a pretty good one. Find the average value, let's call it AV to be faster, average value of the given function y equals 3000 e to the 0.05 t on 0, 1. So this is 0, 10. Okay, let's increase the interval. This is a nice idea. This is exponential function. The level of bacteria is growing from 1 to 10. Oh, let's do from 1. Okay, fine. The one is from 1. They keep changing the interval, so that's fine. From 1 to 10. What was the average change? What was the average number of bacteria there? That is a pretty cool idea here. So I actually want to show you this. Let's see. Not too bad. Wolfram Alpha will tell you how it looks like, and what are we talking about here? We're talking about areas. So areas are integrals. Remember that. I wonder why it keeps dancing now. Could just stop. It would be nice if it stops doing that. So let's see. Plot the function. Plot y equals 3000 e to the 0.005 t, 5? Yes, and only 1 0. So the function looks like this. The area below this graph from 0 to 10. Let me do it from 0. Let me do it from 0 to 20 to zoom in a little bit. From 0 to 20, it's exponential function looking like this. We are asked only about from 1 to 10. So the area here, no, we change it from 1 to 10.
Okay.
Here, look at that. It's from 1 to 10.
Sorry. Sorry.
Closing. Yes. From 1 to 10. The area looks like this. If I just want to draw the area, I will just do it very typical way, like so, from 1 to 10. Here's the area. This is just a typical integral. Integral of this, let's call it f of x, this function. F of x dx from 1 to 10. This is the integral. This whole area is the integral. But we are not asked about this integral. This integral will show me how much total amount of bacteria they are growing from second 1 or minute 1 to minute 10. They ask me the average. What was the average number of bacteria for these 10 minutes or 10 days or whatever it is? The average will be somewhere on average. It's over here. Maybe higher. I think it's a little bit higher because it's growing faster. So average value is also this integral from a, well, in this case, from 1 to 10 f of x dx. But what is the difference? Since it's average, we will take into consideration that it was growing only on this interval from 1 to 10, and we're going to divide by the length 1 over 10 minus 1. That is the idea of your midterms. Say you have 3 exams, but you only want to know the average from the second exam to the third one. So you will do 2, grade for the second one, grade for the third one, add up together and divide by 2 versus 3. And you will find the average exam grade there. So this is what we want to do, and this was on. Let's just do it. Your job is to know the formula and just finish it. It's actually nothing too unusual here. Nothing too unusual. Average value will be the integral from 1 to 10. In front, well, okay, fine. Let's make it pretty. In front is a fraction. I usually write down from 1 to 10 right away. And then I see, okay, from 1 to 10, so it's going to be 10 minus 1, which is 9. Your f of x is 3000 e to the 0.05 t dt. This integral will give you the average value. Who wants to integrate? I would do like this, just a second. 1/9 times 3000 of e to the 0.05 t dt. Usually that's what scientists do. They take the constant out, and now see the exponential grows by itself. And now they integrate that exponential growth. When you integrate the exponential growth, growth is a derivative. When you integrate derivative, you get the number. So the number of population. So when I'm integrating the exponential growth, I will get the number of bacteria instead of the speed of growing. Who can tell me what is the integral of e to the 0.05 t? People at the end? No? You see, you all got super quiet when I ask the question, but when I don't ask the question, you guys talk. You want to tell?
The integration of 3,000 e to the power of 0.05 t is 3,000 divided by 0.05 times e to the power of 0.05 t.
E to the 0.05 t. Agree, disagree, add something?
Why not? Oh, yeah, no, you're correct. You just added it to...
Agree, disagree, add something? Anyone? Anyone else? Something missing? No? The bar, exactly. 1 to 10. Don't forget, it's a definite integral, so there's no plus c. Instead of plus c, you have a bar. So you have either or. Plus c when it's indefinite integral, a bar if it's definite integral. What happens with 10? You plug it here. Minus what happens with 1? You plug it here. So you will have 3,000. Well, we could simplify that. 3,000 over this and that gives you 20,000 over 3. Nice. 21, 2, 3 over 3 times e to the 0.05 times 10. Plug the top. That's the formula of the fundamental theorem of calculus. 0.05, plug the bottom. Done. So the approximate average from 1 to 10 of this amount of bacteria was 3,983, or whatever was it. Something was growing exponentially and we were curious what was the average value from 1 to 10 time, say 1 minute, 10 minutes. Or temperature, or anything else you want. What do you think about that? What do you think about that? Kind of doable. Usually students like these topics. Your main job is not to forget, to see two things. One is to notice the question about find average value. Every time we say find average value, you're supposed to have a hint in your brain. Oh, it's a normal integral with 1 over b minus a. Done. If you forget this, you will lose points on the test, but if you remember this, it's a very straightforward problem. So let's do one more example and see if you can read this keyword. Example number 2. So the temperature in capital F, let's do that, I like Celsius one, of a city during the time from 6 a.m. a city during the time from 6 a.m. to, guess what, 6 p.m. on a day is modeled by, on a day is modeled by equation. So someone actually figured out, connected the dots and figured out it was a cubic equation, which is f of t depends on the moment of time. And it was 47 plus 4t minus 1/3 t cubed, where t is 0 represents 6 a.m. where t equals 0 is at 6 a.m. the beginning, and then it keeps growing. Find the average temperature during the time from 6 a.m. to 6 p.m. So what was the average temperature? Find the average, we don't say value anymore, we say what kind of value. Temperature from 6 a.m. And again, we can shrink the interval from 6 a.m. to noon or anything. So that also will change the answer. Because we're dividing by the length of the interval, bless you. This interval will change the whole story. The integral will be the same, but the interval tells you what was the average for the particular interval. That makes sense. So tell me, what is your t in this case, changing from where to where? What do you think? T is from what to what?
0 to 12.
0 to 12. All agree, disagree? What do you think? 0 was here, t equals 0, and then till noon it's 6, and till 6 it's 12. T equals 12. Make sense? So we already know integral will be from 0 to 12. We also know that the term in front of the integral will be 1 over 12 minus 0, because we were asked to find the whole interval average. So average value will be, I will put a fraction 1 over, and then I always, it's my preferences, you don't have to do it, integral from 0 to 12, and then when I see those 0 to 12, I know it's going to be 12 minus 0 over here. For different intervals, different number. Then the function goes inside 47 plus 4t minus 1/3 t cubed dt. Agree? What do you think? Comments, questions? This is the most important part, is to build the integral with not forgetting this important average term in front. That changes everything. The integral itself gives you the area below everything. The term in front of it, whatever we choose it, from 0 to 6, from 0 to 3, and that term shrinks what the average looks like. The average will combine whatever was above average and below average into 1 and gives you the average. Does that make sense? What do you think? So it's 1/12 times. Let's integrate fast. And by fast, I mean, you remember fast integration. All of you should yell very fast and feel confident. What is the integral of 47? 47t. 4t gives you 2t squared minus 1/3 t cubed. 112t to the 4. Okay, now people are shocked about this. How did you get all these numbers? If you're skipping homework and you don't understand what we just did, I shouldn't say you screwed, because you still have time to review it, but you kind of supposed to be on top of this. This is already 2x old material. So let's review it. 4t gave you 4t squared over 2, and that's how it got into 2t squared. And then minus 1/3 t cubed became minus 1/3 t to the 4 over 4. And the more you do it, the faster you can simplify the fractions. Minus 1/12 t to the 4. Ask me, what do you think? Do you feel like you're screwed or not today? Or on the average? Some people are like, it's more or less okay.
Well, I feel screwed, but that's more of a general state of being than in this class.
Okay, general standing is being screwed all the time. But at least you know you still have time to catch up. That is good.
Well, no, I didn't mean in this class. I just meant in general.
Yes, in general, I understand. Plug 12 everywhere you see t, and then plug 0 everywhere you see t. So 12 is the hard one, because 0 gives you 0 everywhere. In this case, 47 times 12. You plug the top. Everywhere you see t, plus 2, don't forget to save all the exponents. If it was t squared, it will be 12 squared. If it was t to the 4, it will be 12 to the 4. Plugged everything carefully. Put huge parentheses. Minus, that's part of the formula. Don't forget 1 over 12 is supposed to be everywhere because it's factored out. Times, plug 0 everywhere you see t. 0, 0, 0. So that's a good one. If I wanted to choose interval from 1 to 12, then we have to calculate more stuff. So, I don't know, just calculate. I don't have any preferences how fast you do it, but in my notes I get 55
The great news is we can simplify a lot.
degrees. Yep, 55 degrees, that's a nice exact answer actually. And that means, even though in the morning, let's see what was the temperature at 0. Who knows what was the temperature at 0? Anyone? Yeah? Okay, Chris, you can shine.
Sorry.
You can shine.
I'm sorry.
Dude.
I'll stop. 47 degrees.
It was 47, how do you know?
What's the constant?
It's this function. At 0, at 6 a.m., T was 0, so it started with 47 degrees, which is chilly. Then at 12, you plug 12 in and you get some kind of number. It will be high. But on average, from 0 to 12, which is from 6 a.m. to 6 p.m., it's 55. So you can plot this function as a cubic function. It's growing, like so. It's a cubic function. That's how I know how to draw it. F of x. At 0, it was 47. Then it was at 0, and 0 is 6 a.m. 6 p.m. is 12. T equals 12. So this is T. T equals 12. That is 6 p.m. If I just calculate the integral below f of x, it will give me this whole area, which tells me all possible temperatures from 6 a.m. to 6 p.m. collected together. All of them were collected together, and it was growing. But on average, it's a good question. What was the average temperature if I have plants growing somewhere, and I know that it cannot survive too low temperatures? Or maybe you have medicine stored in a drawer. What kind of temperature is on average? On average, it's ended up to be somewhere on average. It's literally on average. Average value was 55 Fahrenheit. And for you to understand that when you take this piece above and when you take this piece below, it will add up to this function. So it's literally on average, taking whatever was above, taking whatever was below, and setting to be a rectangle, the average value. How did we do it? By dividing the interval, by dividing the whole integral. By what number? 12. So we divide it by, I would do it like this. We divide it by 12, because that is my T length from 0 to 12, from 6 a.m. to 6 p.m. Makes sense? So that's kind of very practical ideas, to be honest. You should know that this, you will see it a lot in the literature, biological classes, medical classes. What is the average number of medical, when you do the injection in the body, what is the average? You know that the injection is maximum at the beginning and then it dissolves, so it will stop working in 3 hours. What was the average process of that medicine working on the patient? So you will see that quite a lot, and this comes from integration. Good job, people. I think it's good enough for today.